Hello friends, welcome to video tutorial of Simply. In this simulation, we are going to show you the electric field lines due to uniformly charged finite rod. So this is our rod, and for clarity, let's start from the beginning. So let's try to draw the coordinate axis first. Uh, this is X, this is Y, and this is Z. Okay, and now uh, we can also change the length of the rod here in question by this slider. So the electric field lines are like this, and you can see around the center of the rod, the electric field lines are actually radially outward due to symmetry, but at the ends, due to unsymmetry, they are not radially outward but something curved in a different direction. If we put a charge anywhere on the line, and if we want to see the component here, we can see these component and the charge from these icons, clicking on these icons, and the net force is being shown in the white arrow in the direction where the electric field line direct at that point only. And these are the location coordinates of the charge, so we can change the location of charge here, and the force at that point will change accordingly. So let's talk about the case z equal to 0. When the z is equal to 0, the charge will lie along the center of the line. These location coordinates r, theta, z are in cylindrical coordinates. So, as we can see here, z equal to 0, the charge is at the center of the rod, and therefore there is no any other component of it in any other direction. The component is itself the net force here. And in this case, when r is going to increase, the distance of the charge from the line is going to increase, and therefore the electric field intensity weakens, which weakens the force also. If we change the z coordinate of the particle, then the net force is going to change, because the electric field lines are also changing and are not radially outward at any other point. And one more thing to consider here is, when r and z are fixed, then at any angle theta, the magnitude of force is going to be same. Because although not radially outward, the field lines are somewhat symmetrical at particular r and z. So the magnitude of force is going to be same, and the direction of force will be along the electric field line directed at that point. At the center of the rod, you can see that the field lines are radially outward, as we use for approximation. From this view, you can see that the field lines are radially outward. This is the Gaussian surface of the rod, which you can see here.